Welcome back to SQL in the City. Hopefully you've been enjoying the stream and you had a good time watching Grant and Ben try to get monitor on their mobile devices. That was quite interesting. So I'm here today. We're going to talk about how you can do a little bit better, I think, at building software, right, and deliver some value. I got myself and David here. So I've been an advocate for Redgate, and I've been here 12 years, right? And though to be fair, I met Simon in 2002, so I've known the
I
company
see what
for
you're doing
quite
there.
some time.
Yeah, I was going to trump you by saying I've been here 14 years, but
yeah. So I have David Atkinson here, who's done a number of things at Redgate over the years, right? We've known each other a long time now.
yeah. So I started out as a test manager at Redgate, and but most of my career has been in product management. So I call myself a product manager, and I was there right from near the beginning at Redgate. I was product managing SQL Compare, SQL Prompt, and SQL Source Control, of course, and I've evolved those to what we know today as database DevOps, and we'll be covering that later on in this.
And you're an idea guy too, because you came up with SQL Clone.
I didn't come up with SQL Clone. I would say my specialty is taking ideas from elsewhere, the market, others, taking credit for them, and also trying to push them.
You showed me a demo in Redmond about 6 years ago, and Clone has only been around for 2.5 years.
That's right. But it wasn't my idea. There were some other people at Redgate who came up with these things. So I don't want to take credit for it, at least not in public.
Yeah, he's quite modest, but David comes up with a lot of ideas, and he's now working with Oracle quite a bit in Redgate as well.
Yeah, so I've been pushing Oracle, and in fact since 2009, it goes back even further.
But now it's a database DevOps thing. You're pushing Oracle.
It is, and it's doing really well. So we've got lots of hopes about our cross-database story.
Yeah, and we know lots of you run Oracle as well as SQL Server. So I want to start and talk just a little bit about software and some of the things we've seen in the world. And we know these days software is very complex, right? People build big systems, whether you've built this big monolithic embedded system or you're running containers and Kubernetes, it's an issue. And I found some of these interesting problems that have occurred over the years where we haven't built software well, right? That's probably a kind way of saying it.
Yeah.
So in this one, the US NASA organization sent an orbiter to Mars, and they had problems, right? It actually crashed because they went from, I'm going to call them American units, to metric units. Did you know, so my son has always told me, I don't know if you knew this, that there are countries that use a metric system, and then there are countries that have been to the moon.
Very good. I actually had to look up English units because we don't call English units, we call them imperial units. But then I found out that they are different. English units predated imperial units.
I did not know that.
Yes. So
in either case, they're different from metric units.
They are different, and that is it's a problem, and it's a problem that is worth 125 million to somebody.
Yeah. And that's a big problem, right? But it's the kind of thing that this was. I think you were saying you looked at it that it's an integration problem. They didn't integrate their software.
Well, yeah, there were so many failures. I did some research earlier on just to learn about this issue, and that the external contractor, they knew that they had to convert their units, but they forgot. So they didn't have the processes in place. But that should be fine because there should have been integration testing between what they produced and what NASA then integrated into the orbiter. But the extent of the integration testing there was making sure that the file output could correctly load in to the other unit, but they didn't test the data in the file to make sure that the data did what it was supposed to do. So the simulations were pretty much non-existent. So right. they did a bunch of modeling, and it just didn't work out. There was no integration testing, no realistic simulations on real-life data.
All right, and that's one of the things we certainly see in the database world as well, that we've got to make sure we not only test how the application works, whether it's C# or Python or Java. We've got to test the code in SQL Server, but we have to do it with different data. We have to know what the data is going to do.
And you have to do it with production-like data.
And you do.
Yes.
You really need production-like data. Yeah. All right. So it's one of those things we thought was relevant. This other one I think is kind of amazing too. I think this is maybe more of a little DevOps story, right, in terms of trying to do things. So those of you who've never heard of Knight Capital, they were a trading organization in the stock market, and there was a day where they deployed code to servers, right? So they had 8 servers running a production workload, and they tasked the gentleman with deploying code.
It wasn't me.
It wasn't David, no, but they tasked somebody with this, and a human put this code on correctly on 7 servers and not on the 8th one.
Yep.
Right? And if you've ever seen an animation of this, I've seen some sped up animations where they show the dollar amounts per minute. And they obviously have to speed it up because 30 minutes. But if you compress that down, it's incredible to see how quickly they lost $440 million.
Yep, that's more than the orbiter, the Mars orbiter.
That's
by a long way.
Yeah. And this was kind of amazing, right? And we emailed briefly about this, that it's not enough to just do a deployment, right? We've got to verify that.
That's right, yeah.
And that's one of the things we do with our tools, right? That we don't just deploy software databases.
So there were a bunch of mistakes here. So relying on one human being to deploy is a mistake, of course, because there were no checks. There's no validation that the deployment worked. But even given that, there were some early mistakes. There was a feature flag, for example, that they reused. This was a feature flag that was associated with a test feature that, because it was only run in test environments, would buy high and sell low, which is obviously the opposite of what you want to do. But this was never meant to go into production. And they hadn't used this feature for a while, so they thought, let's reuse the same GUID for our new release, because no one's ever used this. But of course, that's the thing that didn't get deployed to that 8th server. And when they turned on the feature flag to turn on the new feature, what it did is it activated this
trading algorithm.
Yeah, and that's how it failed.
So why would you reuse a GUID feature flag? Are you running out of GUIDs?
Well, exactly. No, they just presumably thought it was a waste.
Yeah.
Why not reuse this?
Feature flags are dangerous.
I'm sure in hindsight, the person who made this mistake will not make this mistake again.
At least not at Knight Capital, right?
Yes, it's probably no longer working for Knight Capital, I should imagine.
Yeah, I don't think there's Knight Capital anymore. Yeah. But in any case, one of the things we found over the years, we've worked with a lot of customers over the years. I've been in different systems. Databases have particularly been a bottleneck in building software, right? For a variety of reasons. And some of these things are listed, right? So SQL is a very odd language. I think you might agree, right? I think you're more of an application guy, but SQL is a very odd language in how it's structured. I would argue it's a horribly broken language as well. But in any case, we certainly have the languages we use in OLAP or Cube servers as well, MDX or DAX or things. And XQuery, do you like writing XQuery?
I've never written XQuery. I wouldn't go anywhere near it.
They're very hard things. And for developers, this often means they don't do a good job, or the database developers that are proficient become bottlenecks in just getting work done, right? And those are the problems that I know you've been trying to solve for a long time with the various DevOps type products here at Redgate. How do we make this better? And those have been challenges. And then certainly the persistence thing is an issue. I always talk to people about DevOps and say that if I could drop and recreate tables, life would be really easy. Deployments would be no problem, right? We could roll back, roll forward.
Of course.
But you've worked in Compare, you've worked in SQL Source Control.
Yeah.
You're really careful about anything that could lose data, right?
Yes, we have lots of warnings in our products that let you know when data will be lost.
Right, and they annoy me because sometimes I'm moving quickly in reversing demos and stuff, and I always see, hey, this is going to drop data, be careful. Are you sure you want to do it? But it's important because that is a huge problem, right? And then lastly, as somebody who's been a production DBA and a manager of a DBA group, we get worried about things because typically it's the DBA that gets called and not the developer when things break. Though maybe that's changing a little with DevOps, you think?
Yeah, I think so, but I still think it's the DBA. So the DBA, that's why the DBA is such a stakeholder in the DevOps process, because even though developers are more empowered to do the deployments, I think the DBA is still the person who is ultimately responsible.
Right.
So maybe this is a transition phase, or maybe this is the way it'll settle.
In any case, one of the things I do when I talk a lot about this is that we don't want the database to be the bottleneck. We want it to move quickly with the application, right? It doesn't mean bad modeling, it doesn't mean poor design or anything else, but it does want to move quicker, right? And so I actually remember these days.
Yeah, so we've got a bunch of slides here that will run through sort of Redgate's history a bit, because I thought it'd be a bit fun since it's the 20th anniversary. But before Redgate, so 1999 and earlier, this is more or less how people deployed. So there was a developer who would have a development database, make changes on that at some point, and it was a bit waterfally in those days. You'd have to deploy to production. And that's fine because you work out the differences between development and production, usually reverse engineered because you probably haven't written those down in those sort of 18 months of development.
I did, but
okay. Well,
very few of us did that.
Very few people wrote them down, but that's okay because it's a one-off task. It's very painful and time-consuming, and you're deployed to production.
And by the way, this is the Knight Capital situation, right, where a person, a man or woman, is responsible.
That's true. Yeah.
Yeah.
Yeah, and they should have known better because that was recent. Yeah.
Yeah.
In summary, so human error is very likely if there's a human being authoring the changes.
Hey, by the way, before you do this, have you ever made a bowl?
I haven't, no.
It's a very hard thing to do.
Is that you in the photo?
It is not me, but I have made a bowl before, and it's much scarier. I've actually turned wood into a cylinder, and that's not too hard, but the bowl thing is harder.
That's good to know.
Yeah, in case you want something to do on the weekend.
Great. Back to database development. So human error is likely. It's very time consuming, but that's okay because it's still just once every 18 months. And changes will be missed, which is less okay, but hopefully you'll have done some testing. But it's enough for that to be a problem, and it was actually a problem at Redgate back in the day. So this is Redgate's webpage roughly in the year 2000. And I think many people here would be surprised to know that database tools weren't where Redgate came from. Redgate started out as a hosted bug tracking application service provider. So this was the days before hosted software. Redgate was trying to push this model. And this is the product, Aardvark. It's a bug tracking system, and we used it internally at Redgate for a number of years, and I thought it was actually quite good.
I've never used it. I never heard of it
well,
because I always just went to the compare page.
Yes, and as you can see there, redgate.compare, it's a sort of a bit of a pun in there, is there, but as very much the second tool. And this tool was developed because a bunch of Redgate's customers. So Aardvark was a hosted tool, but a lot of customers actually wanted it on-prem. So there was an on-prem version that we would give to customers. Of course, we ended up with a bunch of customer versions, different versions, and we had to keep them up to date. So what Neil Davidson, who was one of the founders of Redgate, did is that he developed a tool to help people upgrade their databases. And what it would do is it would compare their production database with the next version, and then it would, everyone knows how SQL Compare works today. And that was a free download. It was on our website. And it was just quite interesting when the observation was made that there were more downloads of the SQL Compare tool than there were customers of Aardvark. And therefore, the realization was that maybe the value was in this tool and not in the bug tracking tool. So if you fast forward a couple of years into the future, into 2002, you can see that the product ordering has switched. So Compare is now at the top. And we have a product called Ants Load, which is a .NET testing tool that sort of hasn't quite made it. But the important thing here is that Aardvark in a box, because obviously now it was an on-prem tool,
right.
Is at the bottom and is being demoted. I noticed there's a testimonial on the right from SQL Server Central.
Yeah. So my partner actually loves SQL Compare.
Oh, it wasn't you. I did wonder.
No, and Redgate was actually our first customer for advertising.
Okay.
In 2001, and then. I think 2002, he gave them that testimonial.
Look at that Redgate logo.
Yeah.
I haven't seen that. That's
Star Trek.
It's unbelievable, yeah. Anyway, moving on. Oh, well, actually moving backwards. So 2000 onwards, so Compare became Redgate's bread and butter at this point. So SQL Compare was then marketed as the tool. It's making that task of manually authoring the change scripts very easy. So it's taking the manual deployment, it's optimizing manual deployments. And it did it very, very well, and it was incredibly successful at what it did. However, around this time, the Agile movement was really pushing ahead. And what the Agile movement was trying to do is saying that we should release value as early as possible. So we shouldn't be doing waterfall. We should be iterating in smaller cycles.
Right.
And Agile was all based around the sort of like the foundation of source control. Everything first went into source control, and then you took what was in source control and you pushed that regularly to customers.
Right.
And databases didn't have the concept of source control. They were sort of binary blob things in your database, and you push those to
through email.
Well, email was SQL scripts through email, and that was the way it was done. And so it couldn't really play its part in the Agile evolution. So
and for a lot of people, still doesn't, right? And we're still trying to get more people to use source control. It is important.
Sadly, it's still in its early stages, but at least the tooling now exists, so that there's less of an excuse. So this is where Redgate came in. So we're sort of in 2010 now, so maybe halfway through Redgate's history. SQL source control was developed, and this was a tool that's helped convert your database into a format that could be version controlled. So there were existing version control systems in those days. It was like VSS and Subversion and TFS, and now everyone's moving to distributed.
I mean,
Mercurial's gone. So SQL source control did just that. It was a re-implementation of SQL compare that was optimized for that task. It took your database and put it into a version control compatible format so that version control could do all the heavy lifting, because we didn't want to write our own version control tool, of course. You get the history, the audit, the ability to roll back, that single source of truth, the collaboration for free, because you're putting your files in a format that version control systems can understand.
And we're still in the SQL compare kind of manual deployment phase here.
Yes.
Right? So this is still kind of half automated, right? Getting it into version control, but then still manual.
Yeah. So this is getting agile, but it's not CI/CD. It's not continuous delivery. There's no automated deployments in here. But if you fast forward 10 years to today, that's what we have. So we have this solution. So it's more than just a tool. It's a whole organizational, process that you have to have adopted here. But it's based on source control. There's continuous integration, automated release management, or manual release management. You can do a bit of both. Right. And all the way to production, monitoring, backup and recovery, and provisioning production-like instances, and then all the way that goes back to product development, where we have a productivity story as well. Right. And the interesting thing is here that all of these, many of these tools are actually based on the SQL compare technology.
Right. That's kind of amazing, but it shows how important that understanding what is happening, that transparency information thing, which we talk about in DevOps, is critical to this process. In that we've built really kind of a DevOps circle now, right? So the whole thing can cycle through, get those changes out, see how they perform, get some feedback, refresh our data, and then can go on again.
Yeah, that's right. But is that enough?
Is it enough? No, it's not. It's not, right? I talk about this all the time. There's this DevOps acronym COMS. You've heard it, right? So culture, automation, lean, measurement, and sharing. And the measurement, the automation, the lean part, those are really simple things in many ways. Those are the easy parts. But the culture and the sharing and trying to change the way we work is really hard. Okay. A lot of what we do in DevOps has been inspired by, I think, the work Edward Deming did and the Toyota production system in Japan that really has focused on building a better system to get stuff to the customer quicker, right? So they built these amazing production lines where they try to minimize everything they do. They don't want to waste anything, right? No waste product, no waste time. And they really want to focus on what the customers will do. Now, in building something like cars, I think that's hard because as much as you mock it up and let people see it, until they actually drive it, they don't know, do they like it or don't like it, right? So that's tough. But in software, we don't have those restrictions, right? We can get changes out often, right? And we do. How often do you guys release the Oracle changes?
Well, we try to do it every sprint, but although the important thing is that we can release.
Right, you can release.
We can release.
So any day, if I said release today, you could release today.
Well, that's right. So that's the important thing. It doesn't necessarily make sense to the customer to get some changes that are sort of like internal, that don't deliver value necessarily. Right. So you wouldn't necessarily push all changes to customers. But if you needed to, or if you thought they would get enough value by doing that,
if there's a security issue,
or in particular if there's a security issue,
you could release.
You could release, yeah.
Right, and that's one of the things that they're trying to do, right? That they're trying to constantly improve their process, and we do that at Redgate. We're always improving the way we build and release software. But Toyota is doing that too. So they're trying to focus on this pipeline, which is get this thing through, which means eliminating the waste, focusing on the customer, and empowering people. Right, this is a big deal. So I don't know if you've heard they have these andon cords. Have you ever heard
No,
about
I haven't.
that? So you can, the little green thing, kind of on here on the right, they have these little cords all over their assembly line, and these are in all of their plants. And they talk about how anybody on the line can grab this cord and stop the line.
Oh, it's like those things on trains.
Yes.
Yeah, I've never pulled one of those.
Yeah. So they have these in all their plants. And I was actually reading about GE because they went and looked at this 20 years ago, and they actually put it in some of their jet engine plants. Because the idea is they would rather stop and make sure there's no problem now than deal with the problem later, which seems similar to testing your software before you release it. Right?
Okay.
Let's find out what's wrong early.
Okay, it's like if continuous integration flags an issue,
Right.
then you get the red flashing light appears above your desk, which is what happens at Redgate. It's very distracting, which I think is the point.
It is the point, right? So let's stop and fix it now rather than delaying it. How often do you think they pull the Xandon cords in a plant a day or a year?
I don't know. It's either zero or many times. I'm not sure how this is going to work, because I guess they wouldn't want to. So they'll have optimized their processes so they don't have to.
So interestingly enough, it is very hard for people to learn to pull the cord. Like there is a lot of trepidation, both in Japan and in America, and I assume in Britain as well. But they pull this cord over 1,000 times a day.
Wow.
Because what they've learned to do is let's fix problems now rather than delay them till later. And that's kind of what we're doing, the continuous thing. And part of this optimization and these other things are we want to smooth this process and find problems early as left, right? We talk about the shift left piece.
I guess you need no culture of blame. Yeah.
You do, right? And so all of these things are things that we want in software as well.
Yeah.
We want to be able to work as a team. We want to continuously improve and get better over time. And then certainly we want to have quality in our code from the very beginning. And this is one of those things I think Redgate does well. By capturing things in prompt and snippets and by putting in version control, we capture good things as well as bad, right? If you write bad code, we can't fix that. But when we capture good code, we make it easy for you to share that with other people, right? And I think that's one of those items that is very important for any sort of manufacturing process, of which software is one.
I think there are things we can do, like static code analysis to identify code smells. I mean, obviously, there's only so much you can do in interpreting code. Unit testing, so you can check that the code is doing what it's supposed to be doing as per the business logic specification. So there are things that can be done.
But there are things we do to enable you and help you get better at it, right? We don't write the code for you. We're not going to say that you should, do a blue-green deployment. They should copy a table or something and then change names or rename it. But we do facilitate those things by allowing you to test things, by providing you with tooling that will, in fact, catch problems early if you write the tests.
That's right.
That will flag them up. That will also version things, so make sure you deploy the correct version of the code to the database. I've had that problem many times, which is amazing. And I think you will have it if you don't have version control, that you just won't know what version to deploy.
Yes, that's true. I mean, that's a challenge we have at the moment, because even some of the customers who have adopted most of the Redgate tooling and the entire DevOps solution, sometimes they get to the point of deployment and say, well, actually, we want to cherry pick our deployments. So they're willing to have done all the testing, all the work to test, to validate this specific version, and then at that point they fork out and say, well, actually, I want to deploy some of it, which of course that hasn't been tested in isolation.
Right. And I don't mind if they want to cherry pick, but then they have to push that back through, right?
Exactly.
You got to branch and push that back through, and we try to make that easy.
Yeah.
So I'm curious, do you know this movie?
No, but I looked at your slides beforehand.
So you know.
and I looked at YouTube, and I got a flavour of what it was like. Yeah. No.
So I saw this movie, this was Gung Ho, back when I was in high school or something, early 80s. And this scene is interesting enough that the Japanese have taken over this company. And the gentleman in blue, he's painting the bottom of the car. So he's doing this undercoating thing. And you see the Japanese guy stop him and saying, look, you're supposed to go here, 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 not everywhere.
Yeah.
Right? We want to improve this process. We don't want to waste our effort. And sometimes I think, in software, we look at our Post-its and we do our things, and we're not really thinking about the entire process. And we certainly don't think about sometimes how we deploy things or what it is. And so part of what we're trying to do at Redgate is give you tools to help you continuously improve, right? And that's a big part of Lean. And that's what this is. So this is Kaizen. This is the Japanese character for improvement. And this is a big part of the Toyota production system and the Lean methodology, is that we are looking to improve ourselves all the time. And I think we want to do this in two ways, right? We want to certainly write better code over time, which means if you have a good idea, I should adopt it, or if I have a good idea, you should adopt it, rather than doing the same thing. But we also want to smooth that process of getting code written and deployed to customers, which I think that's been one of the amazing things at Redgate, that I look now in our Slack, we have Slack bots on different days and different channels that say today's release day.
Yeah, it's just give us a nudge.
A nudge,
a reminder,
right?
yeah.
A reminder that it needs to happen. And we've gotten better to where I think almost every team releases every week or every 2 weeks, which is phenomenal. It's gotten to the point where we have a channel for releases that is just a blur.
Yeah, no, I mute that because there's too much in there.
It's too much in there. It's crazy. It's absolutely crazy.
I have a question, because one of the I think principles of the lean systems, especially the Japanese lean systems, is that people need to be able to empathize with everyone else, and that everyone knows how to do everyone else's job. Is that the case, and what's the benefit of that? Because that's sort of almost against the Henry Ford, everyone has a specific task and knows how to,
Yeah, in some sense it is. I mean, it's not that we are replaceable easily, because certainly your skills as a product manager and as a developer are different than my skills, just blathering on at the conferences. But we both have some idea what the other one does, and part of that is to ensure that the flow of the entire system is smooth. So if we realize what will happen downstream of us or what may be happening upstream of us, we can potentially decide that I should change my job in some way, or I should do something differently that helps flow work. Because it's not about optimizing my job. Right? Henry Ford was like, we will optimize each job. And what Deming found, and what many people have found over the years, is that optimizing each job often results in bottlenecks that don't improve the flow through the system.
So you need to have enough context about how other people who are stakeholders in what you do,
right,
how they use the output of
how they do it, or you need to be able to push feedback back upstream to say, I need transparency in what's coming because it helps me plan my job, or I may implement this feature differently if the architecture is changing upstream of me, or if there's a triage change upstream, I may decide to work on A versus B.
That's interesting, because obviously I would say back in the day, but it's sort of more what we have today is that we have development and ops, and they are still very much separate. I know the DevOps movement is trying to bring them together.
But in most places.
But that's not solving it in that way. It's not because developers know how to do the ops job or ops knows how to do development. It's sort of everyone is part of the same team. It's
part of the team, and they're still specialists in their areas,
yes,
but they empathize and work with each other to understand. What we do in the tooling, right, is we try to package stuff up to make it easier to deploy, right? Yeah. That's what we're kind of doing. But ultimately, the reason the Redgate thing is an entire system is while the developers do a certain thing, we put it in version control, and then we test it, and we produce an artifact, and then we deploy it to a server, we really have to start at the server and say, how will we deploy this thing? And because that determines how we package it up.
That's right. Yeah.
Right. Because we kind of worked backwards, even though we built the products forward. Compare underpins it, but we went, okay, we have to package this, but it can't be in compare format. It has to be in version control format.
That's right.
Right. And then that will determine how can developers actually get it into version control. And so it's this empathy of understanding how I can get the entire system to flow. Even though I may not do the job, I can understand it.
Yep.
Okay? And if we don't have enough of that, then things slow down. Right? I mean, our ops guys that are sitting over here, they know how to do coding, they know how to program. They can certainly tell us sometimes, would you please do this differently because it makes it easier for us, or can you add instrumentation, that kind of thing. And certainly as developers, we want to get work done, but understanding their job means that we perhaps think differently about how we implement things, or we work within other constraints because I don't need them to support 10 operating systems and 45 frameworks and other things like that.
Yeah, that makes sense.
Right. So I think one of those underpinning things of the DevOps is that systems thinking of considering the entire thing. I think sometimes we do get the feedback piece pretty well, but we don't always act on it. And then certainly many of us are afraid to experiment and try different things. I know you're not, right? You're the experimental guy.
You say that.
But that is, compared to most developers, you experiment quite a bit. You pick and poke and try different things.
I try.
You try?
I try to different degrees of success,
but it's
I can but try.
I think you brought us some things. You helped get SQL Clone done. You've getting the Oracle thing. I think it looks fantastic.
Thank you.
The Oracle thing is exciting. It's is EAP now? It's beta. It's alpha.
Yes. It's alpha. It's private. It's private beta.
Okay.
Yeah. But anyone who's interested in trying it out, please get in touch.
You should, and it looks fantastic. Like it really is a really neat tool to bring DevOps to the Oracle side of things, and then probably other platforms at some point.
Yes.
Yes.
Possibly next year.
So I think really, what we want you to think about is getting things done right and getting value out there and flowing it through your system in the databases. That's really what I want you to do. Rather than think about my task or my post-it, think about getting these features in front of somebody that can use them and give you feedback and tell you yes, no, more or less, something like that, right? That's what we're doing. And then build that culture of continuous improvement. That really makes a huge difference, because the way I wrote code 20 years ago is not the way I write code today. I think it's probably the same for you.
Yes, because copying and pasting from Stack Overflow wasn't possible those days.
So
Yeah.
Stack Overflow helps developers today. That's a good thing to know. SQL Compare is really the fundamental piece of all we do, right?
Yes.
It's been amazing how the tool's grown.
It's incredibly reliable, and it's been the foundation of so much of what Redgate has produced. Yeah.
All right.
Yeah.
Well, hopefully you enjoy this. Next, we've got Kathy talking about, I don't know. Really don't know what Kathy's talking about. Something interesting, so stay tuned. All right. Thanks, David.
Hey, thank you.